Okay, and then different behavior. So-called wave tunneling or wave blocking behavior is happening over here. And also, this is the case when we have some string that has this length and maybe this length and this length, different characteristic impedance. Therefore, there will be some transmission and reflection, and some transmission and reflection, okay, and then transmission. So depending on the size of this chamber, some wave can be blocked into the chamber and some wave can be propagated. Okay? I also would like to say about this kind of pipe. Okay? The boundary condition over here is a rigid boundary condition. And the boundary condition over here is pressure release boundary condition. Therefore, the pressure over here should be same as pressure over here. Right? So if you see the case, the pipe, when I blow it, this should be same as the ambient pressure, and the boundary condition over here is a rigid boundary condition. And pressure over here should be maximum. And pressure over here should be 0, meaning that equal to the ambient pressure. So the wave that can be constructed over this pipe would be like over here maximum, and over here is 0. So it should look like that. And that corresponds to quarter wavelength. Right? Because one wavelength, these are the one wavelength. So quarter wavelength is the same as L. L is the wavelength, L is the length of the pipe. Therefore, lambda is 4L. And the corresponding frequency is equal to, so that is the frequency that we can hear from this pipe. Right? And again, if I use this kind of pipe in a duct, then what will happen? There will be a big impedance mismatch. Okay? Therefore, it will block the sound of that frequency. Again, for musical instruments, when I blow this, and you can see that there is a hole. The hole, the boundary condition of the hole over here is approximately pressure release. The pressure over here should be same as the ambient pressure. If I block every hole over here, then pressure over here should be same as ambient pressure. So same ambient pressure. Therefore, I will get the maximum pressure at inside. So the pressure distribution would look like that. So the length corresponds to what? Half wavelength. So when I block every hole, if I open the middle, pitch go up, right? Because half wavelengths get small, about half of the wavelengths that I demonstrated before, right? Of course, the musical instrument player, that he or she does not care about half wavelength, so on. He never calculate that kind of things when he or she play the music, right? But that is the science. Okay. So if I block this hole and open this hole, then the pitch will go up because the length is shortened. Right? So every blowing musical instrument follows this quarter wave or half wavelength law. Okay? But this is just the beginning, because this is for the case when I excite the pipe with relatively small pressure. But when I excite high, it go up. And then I didn't explain why. Right? So when you have Korean musical instrument, you did not move your finger, but you can make higher pitch by blowing, changing your blowing power. Changing blowing power often induces some nonlinear effect. If you don't know well, then we always, oh, that is nonlinear. That is very convenient. So I will continue to talk about Dr. Acoustics problem in the coming Thursday. And this is the tip to prepare our final examination. First, to try to grasp basic fundamental concept. Okay, key is you have to understand the impedance. Okay, look at the problem through the impedance window. And then you write down every measure, meaningful measure. For example, KL. Okay. The length divided by wavelength. For example, when you study the radiation, okay, we look at the radiation efficient with respect to, for example, Ka. A is the diameter of the monopole, right? And the Kr determines how far away from the source. That sort of things. Driving point impedance. Certainly the starting point to understand the radiation. That sort of things. Okay? And then you look at the homework problem. If you do the right thing on homework problem, and if you have a right concept and fundamental concept, then you will get at least A-. And you have a better understanding on analysis and so on, then you will get A+. If you do not understand the final fundamentals, then you will get B+, B0, B-. And if I regard you that you did not understand at all or only partly the fundamental concept, then you will get C. In the graduate school, C means okay?